Imagine being a student and getting to send something you built into space.
Wow.
That's the incredible opportunity CubeSats are creating.
It really is.
They're these tiny satellites about the size of a loaf of bread,
Yeah.
making waves in astronomy and opening doors that were once only a dream.
Yeah.
Welcome to Cosmos in a Pod, Space and Astronomy series.
Yeah.
Today we're diving deep into the world of CubeSats.
Sounds exciting.
Okay, so you've piqued my curiosity.
Right.
What exactly are CubeSats and how did they become so impactful?
Well, CubeSats revolutionize space exploration
Okay.
by making it more accessible.
Okay.
Imagine a standardized 10 by 10 by 10 centimeter cube. That's your basic building block.
Okay.
Each one weighs just a bit over a kilogram, and you can combine them like Legos
Oh, wow.
to create larger, more complex satellites.
Interesting.
This modular design, coupled with off-the-shelf components, makes them significantly more affordable to build than traditional satellites.
So there's like a DIY kit for space exploration.
Exactly.
But how much cheaper are you talking? Give me some numbers.
It's dramatically cheaper. We're talking about launching a mission for a few $100,000 instead of hundreds of millions.
Wow, that's incredible.
Think about it. Missions that were once only possible for large government agencies
Yeah.
are now within reach of universities, small businesses, and even individual researchers.
That's a game changer for sure.
Yeah.
It levels the playing field and allows for more diverse perspectives
Right.
and research opportunities.
Yeah.
But cost isn't the only advantage, right?
Right.
I mean, what else makes CubeSat so special?
Well, the speed of development is another major factor.
Okay.
Building and launching a CubeSat can be done in a matter of months, not years, like traditional missions.
Oh, wow.
This rapid turnaround is perfect for responding to time-sensitive events,
Okay.
like supernovae explosions,
Got it.
or studying rapidly changing phenomena. Plus, CubeSats can often hitch a ride on larger rockets as secondary payloads,
Oh.
further reducing launch costs and simplifying the process.
Okay, so they're cheaper, faster to develop, and can piggyback on other launches.
That's-
But are they limited by their size in terms of what they can actually do in space?
Not as much as you might think. Despite their small size, CubeSats can be equipped with surprisingly sophisticated instruments.
Okay.
Miniaturized cameras, spectrometers, sensors.
Wow.
They're capable of performing various tasks,
Yeah.
from imaging celestial objects to collecting data on radiation and magnetic fields. It's like having a Swiss Army knife in space.
Wow, that's impressive. So what kind of research are these tiny powerhouses enabling in astronomy?
One area where CubeSats are making a big impact is the study of exoplanets.
Oh, cool.
You see a mission called ASTERIA, which was about the size of a briefcase,
Oh.
demonstrated that these little satellites can detect exoplanets
Wow.
using a technique called precision photometry. It essentially measures the tiny dips in a star's light that occur when a planet passes in front of it.
Okay, but detecting those tiny dips in starlight must require incredibly sensitive instruments.
Right.
How can they achieve that level of precision in such a small package?
That's the remarkable thing about CubeSats and the advancements in miniaturization. ASTERIA, for instance, used a highly stable telescope and advanced software to achieve the precision needed to detect those subtle changes in starlight.
So we're talking about finding planets orbiting other stars
Yes,
with a satellite the size of a briefcase.
exactly.
What other amazing feats are these CubeSats capable of?
Well, their agility makes them ideal for studying transient events, those sudden fleeting phenomena in the universe. Think about gamma ray bursts
Okay.
or supernovae.
Got it.
CubeSats can be deployed quickly to capture these events in real time, something larger, less maneuverable telescopes often struggle with. It's like having a rapid response team for cosmic events.
So we're talking about cosmic paparazzi,
Yeah.
always ready to capture the celestial action as it unfolds.
Exactly. And let's not forget our own Store the Sun dedicated CubeSats like QC, the CubeSat for solar particles,
Right.
are helping us understand solar activity and space weather, which can impact satellites, communication systems, and even power grids here on Earth.
Okay, now that's something we should all be paying attention to.
Right.
Space weather can have real-world consequences. So having a fleet of CubeSats monitoring the sun is definitely a good idea.
Absolutely. It provides us with valuable data that helps us predict and prepare for potential disruptions.
Yeah.
And the applications go beyond our immediate neighborhood. Imagine CubeSats mapping distant galaxies, studying dark matter, and even probing the cosmic microwave background radiation.
It's mind-blowing to think that something so small
Yeah.
can contribute so much to our understanding of something so vast. It really challenges our perception of what's possible in space exploration. Are there any particular CubeSat missions that stand out as shining examples of their capabilities?
Oh, definitely. There's Marco, the Mars Cube 1. This dynamic duo of CubeSats made history by hitching a ride on NASA's InSight mission to Mars in 2018. They became the first CubeSats to venture into interplanetary space,
Wow.
relaying crucial data during InSight's descent and landing on the Red Planet.
Wait, CubeSats went to Mars? That's a giant leap for tiny satellites. What other groundbreaking missions should we know about?
Well, besides ASTERIA, which we discussed earlier, there's HaloSat. This mission focused on mapping the hot gas halo surrounding our Milky Way galaxy. This halo, which extends hundreds of thousands of light years beyond the visible disk of our galaxy, is thought to hold secrets about how galaxies form and evolve.
So HaloSat is helping us unravel the mysteries of galactic evolution. That's incredible. What other missions are out there pushing the boundaries?
There's HUU, the CubeSat UV experiment, which studies the atmospheres of exoplanets to better understand their habitability, and Capstone, which is testing navigation systems in a special lunar orbit, paving the way for the Artemis program to return humans to the moon.
It sounds like CubeSats are playing a crucial role in almost every aspect of space exploration.
They really are. But their contribution goes beyond individual missions. They often complement larger missions, filling in data gaps, providing continuous monitoring, and even acting as test beds for new technologies before they're integrated into larger, more expensive spacecraft.
So they're like the unsung heroes of space exploration, quietly working behind the scenes to advance our understanding of the universe.
Exactly. Imagine swarms of CubeSats acting as distributed observatories, capturing data from multiple perspectives simultaneously. It's like having a network of eyes in space, giving us a much richer and more complete picture of what's out there.
That's brilliant.
Yeah.
And because they're relatively inexpensive, they're also great for testing new technologies without risking costly flagship missions.
You got it. CubeSats are all about pushing boundaries and expanding the possibilities in space exploration. But it's not all smooth sailing. They do face some inherent challenges.
That's right. There are always challenges.
Yeah.
What are some of the limitations of working with something so small?
Well, size, of course, is a factor.
Okay.
Their limited size restricts the size and complexity of instruments they can carry. This affects power generation, data storage, and the overall lifespan of the mission.
So they're limited in terms of how much power they can generate, how much data they can store, and how long they can operate in space.
Precisely. And that brings us to the lifespan issue. Okay. CubeSats typically operate for months or few years, which makes long-term observations challenging. It's like capturing a glimpse of the universe before they fade away.
So they're like the shooting stars of space exploration. Brilliant but fleeting.
That's a poetic way to put it. Another hurdle is communication.
Okay.
Smaller antennas and limited bandwidth mean data transmission can be slower compared to larger satellites.
That makes sense.
Yeah,
And what about space debris?
right.
If we're launching more and more of these tiny satellites, are we adding to the growing problem of junk in space?
That's a valid concern.
Yeah.
The increase in CubeSats has definitely raised concerns about space debris and the potential for collisions with other spacecraft. It's a challenge the space community is actively working to address.
Okay, so there's some hurdles to overcome, but the potential of these little CubeSats is undeniable. They're truly revolutionizing our approach to space exploration.
Absolutely. And the best part is we're just getting started. The future holds even more exciting possibilities for these miniature marvels.
Well, before we dive into the future of CubeSats and what lies ahead, let's take a moment to reflect on the broader impact they're already having.
Sounds like a plan. It's important to consider how these tiny satellites are shaping the future of space exploration and beyond.
Exactly. We'll be back after a short break to explore the broader impact of CubeSats and what the future holds for these tiny but mighty explorers. Stay tuned,
Great. Welcome back to Cosmos in a Pod.
where we're continuing our deep dive into the fascinating world of CubeSats.
These tiny satellites are proving that big things can come in small packages.
We've talked about their advantages, the challenges they face, and their remarkable capabilities.
But now let's shift our focus to the bigger picture, the broader impact CubeSats are having on space exploration and beyond.
That's right. It's not just about the science and the technology. It's about the doors they're opening and the opportunities they're creating.
CubeSats are democratizing access to space, making it possible for a wider range of players to participate in this incredible endeavor.
It's no longer the exclusive domain of large government agencies and billion-dollar budgets.
Exactly. Universities, small businesses, even individual researchers can now send their own missions to space.
This accessibility is fostering a wave of innovation, pushing the boundaries of what's possible in miniaturization, low-cost manufacturing, and autonomous systems.
And the ripple effects extend beyond the space industry.
Tell me more about those ripple effects. How are CubeSat technologies impacting other fields?
Think about the advancements in miniaturized sensors, communication systems, and power management. These technologies are finding applications in everything from telecommunications and Earth observation to disaster response and environmental monitoring.
It's amazing to think that something developed for space exploration can have such a profound impact on life here on Earth.
Absolutely. It's a testament to the power of cross-disciplinary collaboration and the ingenuity that's unleashed when we push the boundaries of what's possible.
And let's not forget about the inspirational aspect. CubeSat programs around the world are igniting the imaginations of young people and fostering a new generation of scientists, engineers, and space enthusiasts.
There's something truly magical about giving students the opportunity to design, build, and launch their own spacecraft, even if it's a tiny one.
It's hands-on learning at its best, fostering creativity, problem-solving skills, and a passion for STEM fields.
It's about showing them that the sky is not the limit when it comes to their dreams.
Exactly. So as we look ahead to the future of CubeSats, what are some of the developments you're most excited about?
Well, for me, it's the potential for interplanetary exploration.
I was just thinking the same thing. Imagine CubeSats venturing out to explore the moons of Jupiter, the rings of Saturn, or even the icy plains of Pluto.
It's a whole new frontier of discovery made possible by the affordability and adaptability of these tiny spacecraft.
We could have a network of CubeSats spread out across the solar system, acting as our eyes and ears in these distant worlds.
And think about the possibilities for astrophysics. With swarm technology, we could create virtual telescopes with unprecedented resolution.
Instead of building one giant, incredibly expensive telescope, we could launch a constellation of CubeSats that work together to achieve the same thing.
Exactly. It's a game changer that could unlock the secrets of black holes, map distant galaxies, and maybe even shed light on the mysteries of dark matter and dark energy.
It's mind-blowing to think about the scientific breakthroughs that can be made with this approach.
And what excites me most is that this is just the beginning.
We're just starting to scratch the surface of what's possible with CubeSats.
As technology continues to advance, who knows what incredible discoveries and innovations await us.
It's a truly inspiring time to be involved in space exploration, and these tiny satellites are playing a leading role in shaping its future.
But with all this excitement, it's important to remember that there are challenges we need to address.
That's right. We can't get carried away by the possibilities without considering the potential risks.
You're referring to the issue of space debris.
Yes, the sustainability of CubeSat missions is crucial.
We need to ensure that these tiny explorers don't become part of the problem.
So what are some of the ways we can mitigate the risk of CubeSats contributing to space debris?
There are several approaches being explored. One is designing CubeSats with propulsion systems that allow them to deorbit safely at the end of their mission.
So giving them a controlled death dive back to Earth where they'll burn up harmlessly in the atmosphere?
Exactly. Another approach is using materials that naturally degrade in space, reducing the lifespan of debris.
And I imagine there are also ongoing efforts to track and monitor CubeSats more effectively.
Absolutely. Improved tracking and monitoring systems are essential for avoiding collisions and maintaining a sustainable space environment.
It's like air traffic control, but for space.
Precisely. We need to ensure that CubeSats, despite their small size, are operating safely and responsibly.
It's a challenge, but one that we must overcome if we want to fully realize the potential of CubeSats for space exploration and scientific discovery.
I completely agree. The future of CubeSats is bright, but it's up to us to ensure that it's also a sustainable one.
Now let's shift gears a bit and talk about another exciting aspect of CubeSats, the potential for international collaboration.
Ah, yes. CubeSats are, by their very nature, collaborative endeavors.
How so?
Well, think about it. Their affordability and accessibility make them ideal platforms for international partnerships.
Universities, research institutions, and even space agencies from different countries can come together, pool their resources, and work on joint missions.
It's a way to break down barriers and foster scientific cooperation on a global scale.
You're already seeing this happening with numerous examples of CubeSat missions involving multiple countries.
Teams from around the world are collaborating on everything from design and development to launch and data analysis.
It's a beautiful example of how space exploration can bring people together.
It really is. And the benefits are immense.
Not only does it allow us to share knowledge and expertise, but it also fosters cultural understanding and strengthens diplomatic ties.
So in a way, CubeSats are not just exploring the cosmos, they're exploring the potential for human collaboration.
That's a great way to put it. It's a powerful reminder that space exploration is not just about science and technology. It's also about humanity and our place in the universe.
Speaking of humanity's place in the universe, there's another big question that comes to mind. Could CubeSats one day play a role in the search for life beyond Earth?
That's a fascinating question. It seems like science fiction, but the more we learn about CubeSats, the more it feels like anything is possible.
You're right, it might sound far-fetched, but the answer is surprisingly maybe.
Really? How so?
Well, consider their adaptability and relatively low cost. They could be sent to explore potentially habitable environments within our own solar system.
Like the icy moons of Jupiter and Saturn, which are thought to harbor vast oceans beneath their frozen surfaces.
Exactly. We could equip these CubeSats with miniaturized instruments capable of detecting signs of life.
They could analyze the chemical composition of plumes erupting from these icy moons, searching for biosignatures that might indicate the presence of microbial life.
It wouldn't be easy, but it's within the realm of possibility.
Sending a fleet of mini-satellites on a mission to find alien life that would be revolutionary.
And even if they don't find definitive proof of life, the data they collect could provide invaluable insights into the potential habitability of these distant worlds.
It's an exciting thought. So as we continue to explore the world of CubeSats, it's clear that these tiny satellites are having a profound impact on space exploration and beyond.
They're democratizing access to space, driving innovation, inspiring new generations, and pushing the boundaries of scientific discovery.
And they're doing it all with a level of affordability and adaptability that was unimaginable just a few decades ago.
It's a remarkable story of human ingenuity and the power of collaboration.
And it's a story that's still being written. The future of CubeSats is bright, full of possibilities.
Who knows what incredible discoveries and breakthroughs await us thanks to these tiny but mighty explorers.
Let's take a short break to delve into some specific examples of CubeSat missions that are pushing the boundaries of space exploration. Stay tuned. Welcome back to Cosmos in a Pod.
Where we're wrapping up our exploration of the amazing world of CubeSats.
These tiny satellites are truly revolutionizing the way we explore space.
We've covered their advantages, the challenges they overcome, and the vast potential they hold for the future.
And we've touched upon their broader impact on science, technology, and even international collaboration.
But now it's time to zoom in on some specific CubeSat missions that are pushing the boundaries of space exploration.
I'm eager to hear about these trailblazing missions.
Let's start with a mission called QE, a CubeSat UV experiment.
Cute. I love the name. What's its mission objective?
QE is designed to study the atmospheres of exoplanets, those planets orbiting other stars. It's specifically focused on understanding how these atmospheres escape into space.
Why is atmospheric escape such a crucial area of study?
Well, the rate at which a planet loses its atmosphere can tell us a lot about its potential to support life as we know it. If an atmosphere escapes too quickly, it can make a planet inhospitable.
That makes sense.
Yeah.
So how does HUD, a satellite the size of a cereal box, manage to study something as complex as atmospheric escape on planets light years away?
It's quite remarkable. SUIT uses a specialized ultraviolet telescope to observe the light from exoplanets as they pass in front of their host stars. By analyzing this light, it can detect the signatures of escaping gases like hydrogen and helium.
So it's like a cosmic detective sniffing out the escaping atmospheres of distant worlds. That's incredible. What other missions are out there that showcase the ingenuity of CubeSat technology?
Another fascinating mission is HaloSat, which is focused on studying the vast halo of hot gas that surrounds our own Milky Way galaxy.
A halo of hot gas surrounding our galaxy. That sounds intriguing.
Yes, this halo extends hundreds of thousands of light years beyond the visible disk of our galaxy. Astronomers believe it holds clues to the formation and evolution of galaxies.
So HaloSat is helping us understand the bigger picture, the grand story of how galaxies like our own came to be. But how does it actually study this halo?
HaloSat uses sensitive X-ray detectors to map the distribution and temperature of the hot gas in the halo. By studying these properties, astronomers can gain insights into how the halo formed, how it interacts with the rest of the galaxy, and what role it plays in the galactic ecosystem.
It's amazing to think that a tiny CubeSat can help us unravel the mysteries of something as vast and complex as a galactic halo.
Indeed. It speaks to the power of innovation and the potential of CubeSats to contribute to fundamental astrophysical research.
What other missions out there highlight the versatility and adaptability of CubeSats?
Well, there's Capstone, which is a Pathfinder mission for NASA's Artemis program. Remember, Artemis aims to return humans to the moon, and Capstone is playing a crucial role in preparing for that ambitious endeavor.
That's right. Artemis is a landmark mission. So how is a tiny CubeSat contributing to such a large-scale human spaceflight program?
Capstone is testing a unique lunar orbit called a near rectilinear halo orbit, or NRHO for short. This orbit is special because it's very stable, requires minimal fuel to maintain, and provides excellent coverage of the lunar South Pole.
Why is the lunar South Pole so important?
That's where NASA plans to land the first woman and next man on the moon. The South Pole is thought to contain valuable resources like water ice, which could be crucial for establishing a sustainable human presence on the moon.
So Capstone is essentially scouting out the landing site, ensuring its safety and viability for future human explorers.
Exactly. And while it's doing that, it's also collecting valuable scientific data about the lunar environment, including its gravity field and the interaction of the solar wind with the lunar surface.
It's a testament to the fact that CubeSats can contribute to both human exploration and scientific discovery.
Indeed. And speaking of scientific discovery, let's talk about another exciting mission called Lunar Flashlight.
Lunar flashlight, that sounds intriguing. What's its objective?
Lunar Flashlight is designed to use lasers to search for water ice in permanently shadowed craters at the lunar South Pole.
We talked about water ice being a valuable resource on the moon. How will lunar flashlight search for it in these shadowed craters?
It will reflect sunlight into these dark craters and analyze the reflected light using a spectrometer. The way the light is reflected can tell us about the composition of the surface within the craters, revealing the presence of water ice.
So it's like shining a flashlight into the dark corners of the moon, searching for those hidden reserves of water ice.
Precisely. And this information will be crucial for planning future lunar missions and potentially establishing a long-term human presence on the moon.
Well, I think it's safe to say that CubeSats are exceeding everyone's expectations. They're proving that size doesn't matter when it comes to making significant contributions to space exploration.
I couldn't agree more. They're revolutionizing the field, making it more accessible, more affordable, and more innovative than ever before.
And this is just the beginning.
As technology continues to advance, we can only imagine the incredible discoveries and breakthroughs that await us.
CubeSats have opened up a universe of possibilities, and it's an exciting time to be following their journey.
We hope you've enjoyed this deep dive into the world of CubeSats.
It's been a fascinating exploration of these tiny but mighty explorers.
And we encourage you to continue learning and exploring.
Keep looking up at the night sky and never stop wondering about the mysteries of the universe.
Don't forget to follow us on social media for more cosmic insights.
And subscribe to Cosmos in a Pod and our YouTube channel for more incredible journeys into the universe.
Until next time, keep exploring and keep dreaming big.